Hello. In this video, we will learn about chemistry. We will cover the topics of states of matter, atoms, molecules, and the nitrogen cycle. Chemistry is the study of the composition, structure, and properties of matter. But what is matter? Matter is simply everything. The dirt on the ground is matter. The air around you is matter. Rain is matter. You are made of matter. An important law of matter is that it cannot be created nor destroyed. Matter comes in four states: solid, liquid, gas, and plasma. Solids have a set volume and shape. Looking at our real-life aquaponics model, the leaves on a plant are solid. They stay the same shape unless something happens to it, like it is ripped or squished, and they take up the same amount of volume, or space, at all times. The molecules in a solid move very little and are tightly packed together. Next are liquids. Liquids have a set volume, but their shape changes depending on the container they are in. For example, if you put a liquid in a square container, it will look like a square, but if you put it in a circular container, it will look like a circle. But a solid's shape won't change depending on the container it's in. The water used to nourish the plants in the aquaponics model is an example of a liquid. The molecules in a liquid move around more freely than a solid and are less tightly packed. The next state of matter is a gas. A gas doesn't have a set volume or a set shape. The gas will take the shape of its container, but also the volume. The molecules in a gas spread as far apart as possible to try and fill their container evenly and move quickly. The last state of matter is plasma. Plasma is like a gas, but it is ionized, meaning the atoms of a plasma are charged, and they move even faster than the molecules of gas. In the aquaponic system, there is no plasma present. Atoms can have a positive, negative, or neutral charge. Atoms are made of three types of particles: protons, neutrons, and electrons. Protons are positively charged and found in the nucleus of an atom. Neutrons have a neutral charge, neither positive nor negative, and are also found in the nucleus of an atom alongside the proton. They provide weight and stability. Lastly, electrons, which have a negative charge, are found outside the nucleus in something called the orbitals. Atoms have multiple orbitals to fit all of the electrons. Ions are atoms with a different charge due to a different number of electrons. Isotopes are atoms that have a different number of neutrons than are found in normal atoms of that type. This affects its stability and may affect its chemical properties. Atoms come in forms based on how many protons and electrons they have. These atoms are called elements. Elements cannot be broken down into smaller pieces, which makes them very special. Scientists organize these elements into a grid called the periodic table. Each element has a square on the periodic table. It goes from hydrogen with 1 proton and electron to oxygen with 118 protons and electrons. Within each square, there are multiple points of information. At the top of a square is an atomic number, which tells you how many protons and electrons the element has. Below that is the full element name underneath a symbol, which is a shortened version of the name. At the bottom of the square is a number called the atomic mass, which tells you how much the atom weighs. All the elements in the same column, called a group, have the same number of valence electrons. Valence electrons are the electrons in the outermost orbital. Atoms that share the same number of valence electrons have similar properties. One property they can share is ionization. Ionization is when a neutral atom becomes charged. Ionization energy decreases from the top to the bottom of a column. Going from left to right, down a row or a period, atomic radius, which is atom size, decreases. As you move to the right, it is harder for atoms to share electrons with other atoms because they are more tightly packed. Sometimes, atoms join together to make a molecule. To do this, they either share or exchange electrons in their valence orbital. When they share electrons, they make a covalent bond. Sometimes, one atom will give another atom an electron to form an ionic bond. Common molecules found in the aquaponic center are NH3, ammonia, CO2, carbon dioxide, and H2O, water. Ammonia is excreted through the fish urine, carbon dioxide is released from the fish through respiration, and water is used to nourish the plants and provide a habitat for the fish. Going back to our point that matter cannot be created nor destroyed, let's look at an example of how the molecules change and flow throughout the aquaponic system. The white Nile tilapia are fed a food filled with nitrogen, an important component in their diet. Their body processes the nitrogen and turns it into ammonia, which they excrete out through urination. The ammonia travels through the water and goes through the biological filter, which turns the ammonia into nitrite, NO2, through a process called nitrification. The nitrite goes through the nitrification again to produce a similar compound, nitrate, NO3. The nitrate flows through the water to the plants, which use nitrate as a food to help them grow. Another example is CO2, carbon dioxide, which is transferred between animals and plants. Animals breathe out carbon dioxide as a byproduct from cellular respiration, the cycle which creates ATP, or energy. Plants use carbon dioxide to go through the process of photosynthesis, which creates sugars for them to create energy out of. When they are done with photosynthesis, plants release oxygen, which animals breathe in.